Okay, now let's work on section 15.8. That's spherical integrations, triple integrals using spherical coordinate system. Keep in mind that our theta is from 0 to 2 pi, and then our phi is from 0 to pi. Okay, and rho, of course, from 0 to infinity. Okay, now number 24. Evaluate this triple integral where the solid E is hemisphere with rho with rho 3, right? This is rho squared less than equals to 9, and the y is positive. So the y is positive. So y is positive means the theta is from 0 to 2. The theta will be from 0 to pi. Okay, so triple integral from 0 to, so the d phi is from 0 to pi, the theta is from also 0 to pi, the d, I write my phi but I use rho. The rho will be from 0 to 3, okay, and rho squared sine phi, right? Okay, now then the y squared then becomes, is it rho squared or just rho? I somehow think, let me check again. I forgot. So this is d rho, this is rho d phi, and this will be rho sine phi d theta. Oh yeah, rho square. Okay, and the y will be, I wonder what's the y. Y is r sine theta, but r will be phi sine rho sine phi. That's the y then, huh? Okay, so this is rho squared sine squared phi sine theta. Sine squared theta. The domain is a rectangle. It's all constant, right? And it's separable, so the integral from 0 to pi of sine cube phi d phi times integral from 0 to pi of sine squared theta d theta times integral from 0 to 3 of rho to the 4th d rho. Okay, the first integral That's 1 minus cosine squared phi, right? That's sine squared phi, sine phi d phi integral 0 to pi of 1 plus 1 minus cosine 2 theta over 2 d theta, and the last one is 1/5 rho to the 5th from 0 to 3. Okay, that will be, if my u equals to cosine phi, du will be negative sine phi d phi. I know this will go to 0. Okay, so this will be integral from 1 to negative 1, 1 minus u squared negative du times 1/2 times pi times 1/5 times 3 to the 5th. It's integral from negative 1 to 1, 1 minus u squared du times 3 to the 5th pi over 10, which I can just put at the front. 2 times 1 minus 1/3, 4/3. So 3 to the 5th pi over 10 times 4/3. So 81, 162 pi over 5. Okay, that's for number 24. Number 30. Find the volume of the solid that lies within the sphere with rho equals to 2. This is rho squared equals 4. So rho equals to 2. Above xy plane means the c is positive, which implies the phi will be from 0 to pi over 2. Okay, below this cone, z equals to r. Below that cone. So this part here, right? Which means the above xy plane, below the cone. Oh, but that angle is 45 degrees. This is pi over 4. Now I can update my phi becomes from pi over 4 to pi over 2. Okay, so triple integral from 0 to 2 pi, that's for the theta. For the phi, that from pi over 4 to pi over 2. Within the sphere 0 to 4. Okay, for the d rho, and then rho squared sine phi. Independent of theta, so that's 2 pi integral from pi over 4 to pi over 2. Because the domain is a rectangle, quote unquote, and the integrand is separable, right? So the phi will be from pi over 4 to pi over 2 of sine phi d phi integral from 0 to 4, so rho squared d rho. times this is 1/3 rho cube, so 4 cube. This is 2 pi. That's -0 plus radical 2 over 2. Oh, so for cube, this is cube. So that will be what? 4 cube is what? 64 radical 2 pi over 3. That's the volume. Let's check. Actually, we can compute this manually by geometry. That's basically the volume of a circular cylinder that you cut the cone away. Right? You cut the cone away. So let's see, what is the volume of that cylinder? What is the height, first of all? The height will be... Hold on. This is... No, it's not though. It's not. I'm sorry, it's not. It's actually looks like this. Within the sphere, above XY plane, below the cone. Now I start questioning myself. Below the cone, within the sphere. So is this what it looks like instead? So something not right with mine though, but above XY plane. So it should be this one, right? Like in 2 dimension, if I draw it in 2 dimension, it will be... I'm referring to this part here that we revolve about the z-axis. You see, right? That's within the sphere, above XY plane, below the cone. Right? Yeah, that's what it is. So it's basically the hemisphere, and then you cut the cone, the ice cream cone away. Okay. What is the volume of this hemisphere though? 2 over 3 pi r. Now that's where I make a mistake. The radius is 2, not 4. So the radius is 2. Radius is 2. Radius is 2. This is 2 cube 8. Now this makes more sense. That's for number 30. Oh, anything else? Last one. Oh, there are 2 more. I will just set them up. I will not work it out anymore because the time. So find the mass and center of mass of solid hemisphere of radius a. If the density, solid hemisphere, if the density, let me use density as delta. Density is proportional to the distance from the base. From the base. Which base? Oh, sorry. Solid hemisphere. So it is a hemisphere. Let's say this is the hemisphere. So the theta will be from 0 to 2 pi. The phi will be from 0 to pi over 2. The rho will be from 0 to a, right? And then the density will be proportional from the distance to the base. That's basically equals to z. But the c equals to rho cosine phi. Okay, so the mass will be triple integral of the density rho cosine phi rho squared sine phi d phi d theta d rho. I think we can reverse the order that way. So the rho is from 0 to a, the theta from 0 to 2 pi, and the phi is from 0 to pi over 2. It's separable with domain rectangle. So integral from 0 to a of rho cubed d rho times integral from 0 to 2 pi of d theta, integral from 0 to pi over 2 of cosine phi sine phi d phi. This will be a to the 4th over 4 times 2 pi times 1/2 integral from 0 to pi over 2 of sine 2 phi d phi. That's pi a to the 4 pi over 4 times 1/2 cosine. So it's, just 1/2 then. Yeah, this guy equals to 1/2. You try it, you will see that's the case. So the answer is a to the 4 pi over 8. That's for the mass. Now how about the center of mass? The x bar by symmetry, in fact yx bar, y bar, coming from the moment with respect to the yc plane, the moment with respect to xc plane, you will see both of them equals to 0 by radial domain and density. Okay, the setup will be like this. The moment with respect to yc will be triple integral, okay, over solid, let's call this hemisphere, right? And then the x component will be, well, the distance from yc plane will be x with density rho cosine phi, okay. Maybe I put it this way, the density d phi, like that. But you will see that because of the fact that it's radial, so it's symmetric with respect to yc plane, you will see this is equals to 0. Likewise, the moment with respect to xc plane is triple integral over the hemisphere y density d phi, you will also find that to be 0. Now, the moment with respect to xy plane is the one different. This will be c density d phi. But that the density is also z, right? So we will get c squared d phi. And then you do the substitution, change of variables, so on and so forth from there. Okay. Number 36, find the volume of the smaller wedge cut from the sphere with radius a. So we have a sphere with radius a by two planes with angle pi over 6. So let's say this is the first plane and this is the second plane. The angle here is pi over 6. Okay, so we are talking about this solid here. But it's to the, not only in the first octant, but also below that. Okay, also below that. Okay, so then the theta will be from 0 to pi over 6. The phi will be from 0 to pi, and the rho will be from 0 to a. Right? The volume will be what? Actually, if you think about this, this is actually the volume of the sphere divided by 12, huh? Right? So that will, the volume of the sphere is 4 over 3 pi r cubed over 12. That's pi over 9a cubed. That's supposed to be the volume. But if we do the integral, let's see if we get the same result. So the volume will be triple integral. The rho will be from 0 to a. The phi will be from 0 to pi. The theta will be from 0 to pi over 6 rho squared sine phi. Okay, that's integral from 0 to a of rho squared d rho, integral from 0 to pi of sine phi d phi, which is 2 times integral from 0 to pi over 6 of sine phi of d theta. This will give us a cubed over 3. This will give us 1. Is it right? No, 2. This will give us 2. And this will give us pi over 6. Yeah, that's what we get. Pi a cubed over 9. Yay! Okay then. That's for this one here.